Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to start looking at area between curves. When you're asked to find area between curves, you are going to need to be able to draw your curves, and you're going to need to be able to find the points of intersection. So I want to talk about that in this video, and then we'll actually get into finding area between curves in the next video. So if we looked at this example, and I wanted to find the area between y equals x squared and y equals 2 minus x, I would need to draw both of those curves to see which curve's on top, which curve's on the bottom. I would also need to be able to find my points of intersection. In order to find the points of intersection, you make the two functions equal to each other and you solve. So the y values have to be equal. So when x squared is equal to 2 minus x, that's going to allow you to find your points of intersection. In order to solve this equation, let's make it equal to 0. It's a quadratic equation. So we're going to add an x to both sides. We're going to subtract a 2. And then you can use your quadratic formula to solve that quadratic equation. Or what I'm going to do is I'm going to factor. So it will be x minus 1 and x plus 2. So x minus 1 equals 0 will give me a solution of x equals 1. And x plus 2 equals 0 will give me a solution x equals negative 2. So those are my points of intersection at x equals negative 2 and at x equals 1. The other thing that we're going to need to be able to do is draw our curves. So I want to review some basic curves and then some transformations on those curves to help you out in being able to draw them. I've outlined some of the basic curves you're typically going to see in area between curves questions. And I just want to review those and get you familiar with the shape. So if you have y equals x to the n and n is even, so y equals x squared, x to the 4th, x to the 6th, this is what the shape of the graph will look like. It'll be a parabola. If you have y equals x to the n where n is odd, so x cubed, x to the 5th, x to the 7th, this will be the general shape of that curve. If you have a function y equals the nth root of x and n is even, so it's a square root or the 4th root or the 6th root of x, the shape of the graph will look like this. That same function where n is odd looks similar in quadrant 1, but it's defined when x is negative, so the graph is going to look like this. If you have 1 over x, the graph will look similar to this, and if you have 1 over x squared, it looks like this. Now often you're going to see transformations on these basic curves, so let's take a look at what those transformations do to the curve. So again, you'll know how to draw the curve. So let's take a look at our even power. If, for example, y equals x squared would look like this graph here. However, if I had y equals x squared plus 3, what that does is it will shift the curve up 3 units. If that was minus 3, it would shift it down 3. So y equals x squared plus 3 would look something like that. So anytime you add or subtract a number outside of the function, it shifts the function up or down. If you were to add a number inside the square function, so inside that square, that doesn't shift it up or down, it shifts it either left or right, depending on whether it's positive or negative. So if we were to draw the graph of this, it would actually shift it 3 units to the left. I know it might be counter to what intuition says, that if you're adding a 3, it should move it to the right. But when the transformation is done inside the function, it actually is going to be opposite to what you would expect when it's done outside of the function. So this would move it 3 units to the left. The other transformation that you might see is a negative coefficient. If you have a transformation of a negative 1 times your function, that will simply flip your function over your x-axis. So you might run into something like that. However, if you have a coefficient on your function, it's not going to change the shape of your function too drastically. You just want to get an idea of what the general shape is. So I wouldn't be concerned if you had 2x squared or 1/2 x squared. They would both look very similar to that. We don't need to get into the very specific differences in those graphs. Let's take a look at this basic curve, y equals square root of x. This is the shape of that curve. But if I subtract a 2, that's outside of the function, so it shifts it down by 2. So it's this same shape, but shifted down 2 units. So that's what that curve would look like. If I subtracted 2 inside the square root function, that's going to be a horizontal shift. And because I'm subtracting a 2, we're going to shift it 2 units to the right. And you can check a few points. You can say, well, if x is 2, 2 minus 2 is 0, square root of 0 is 0. You can see that shape is going to make sense. And if we multiplied our function by a negative value, it would flip this curve over the x-axis. So this is what that graph would look like. Another 2 graphs that I want to point out is 2 even powers. If you have y equals x squared or y equals x to the 4th, they're both parabola shaped. However, y equals x squared is this graph here. And between the values of -1 and 1, these y values will be greater because they're only raised to the power of 2. Y equals x to the 4th will flatten out more between -1 and 1, because when you take a value, let's say of 1/2, and raise it to the 4th power, it will be less than 1/2 squared. But once you get outside of -1 and 1, when you raise a number to the 4th power, its y value is greater. So just understand that they're similar shape, but the differences will allow you to see which curve is above the other curve in certain intervals. You're going to want to familiarize yourself with these curves because you're going to need to draw them anytime you're asked to find areas and volumes and centroids. And if you're stuck, if you don't know how to draw them, you can always go back to finding maximum and minimum points and points of inflection and so on, which is something that we did when we were looking at applications of the derivative. So use whatever tools you can to get a good representation of the curves so that you can set up your integral correctly. Okay, I think we're ready to start area between curves. Let's take a look at the next video.